Okay, so part C. What's the risk, all right? Risk is another fancy name for probability, really. You answer it as a probability, as a decimal or a fraction, until you start talking about relative risk. All right, so risk of being involved in a car accident for somebody who is 19 years or younger. So that's a bit like a conditional probability. We're not talking about everybody. We're only talking about people in that part of the table. All right? So let's read the question again. The risk of being involved in a cycle accident. That's including people who are injured and killed. We also need to make sure that we divide it by the total amount of people within those categories. So I need to add up those four age bracket numbers, and I need to add up all the values over here as well. And if you made a slight mistake with that, I probably accepted it. I still gave you the achieve mark. But it turned out that the amount that's added up here was 204 in that section of the table. And the bits over here, if you're adding up those four big numbers, you get 1.211740 million. So you get 204, sorry, over what's my number? 1211740. As a decimal, if you did it that way, 0.000168. Rounded. Okay, so that was an achievement question 2. All right, part D, find the relative risk, all right? Relative risk means you need to find two risks and you need to divide them. You do have to think about which one gets divided by the other one. Normally that's quite clear. So find the relative risk, guys, please. Relative risk of being involved in a cycle accident for someone over 40 compared to someone under 40. So those are the two risks that we need to calculate. And then we'll also explain our meaning afterwards, so I'll try not to use up too much space with my calculation side of things. So what I do, the amount of people involved in crashes who were less than 40. So 40 is there, that's my breakpoint. I want to add up the amounts in this, and I want to add up the amounts above it for my two categories. And I want to look at, what does it say? Find the relative risk of being involved in it. Okay, so I'm including injured people and killed people in terms of that as well. All right, the two numbers you get out of that is 453 over, sorry, that looks like a 2, 453 over about 2.3 million. And that's the people who are under 40. Okay, as a decimal, we're getting 0.0, I might have this around the wrong way, so tell me if I'm wrong, please. Something like that? Is that what it comes out as? Okay, for the people over 40, yeah, I'm using up way too much room here. For people over 40, there's 309 people involved in crashes, and there's a bit over 2 million people involved in that category too. 201,1690. Okay, and that number comes out as 0.000189. All right, so those are your relative risk. Those are your risk calculated. If you did those, you got a U mark. Okay. If you did a relative risk calculation by dividing these two things together, and let me just see for someone over 40 compared to someone under 40. So I think I should be having that number on the bottom. I might have done this wrong then. I've got it one way around. My answer says that if you do those divisions that way around, you get 0.811. And that's right. So this must actually be my over 40 category. And that must be my under. Sorry about that. Okay, so relative risk of 0.811. When you're thinking about relative risk, you're thinking 1 means the exact same risk. All right? If the number's lower than 1, it means it's a reduced risk. So people in that younger category have a reduced risk compared to the older people of being involved in a cycle accident. Right? So let me try to write that quite small. So people under 40 have a lower risk of cycle crash than over 40s. Alright, and that's probably very borderline. I might want to talk about how much of a difference it is. So they have about a 19% less chance of being involved in a cycle crash compared to the older people. If you did that calculation and got that, you got a merit mark, which looks like an R. And if you also wrote a good sentence that explains what that number meant, you got a second R mark. So you got 2 merit marks out of that question, possibly.
What's the R?
R stands for relational thinking, meaning you can link a calculation to an understanding, or that you can do multiple steps or something like that. So they use the term relational, and that's why they use R. It is a bit confusing, I agree. Okay, on to our excellence question, this last bit here. But likewise, you may not answer the full question, you can get part marks from it. So it says, discuss the claim, older cyclists, above 40, who are involved in cycle crashes are more likely to die. Okay, that could be true, it could not be true. We need some numbers to back that up, and we need to try to discuss what those numbers are telling us. So it's like a conditional probability again. It's talking about only the people involved in crashes. So if I look at this, the amount of people involved in crashes who are above 40 is that area of the table. I need to add up all those values. Okay, so above 40. It turns out that there are 309 people. 309 above 40 who were involved in a crash. Of those 309, 7 of them were fatal. 7 of them died. So that's the chance of dying if you were involved and you were over 40. For the under 40s, there were only 2 people, I think, who died. Yep, only 2 people who died, but there were more people involved in crashes. There were 453. So I'm getting an indication that it seems like you're less likely to die when you're involved in a crash as a young person compared to an old person. But I would need to compare that, and I would suggest that you do the relative risk thing again. So if you did relative risk, you'd divide these two numbers by each other, and you'd get 5.13. So I'm not going to write that out, but take that fraction and divide it by that fraction, you get 5.13. Saying that you're a lot more likely to die as a result of a crash if you're an old person. Okay, and you can say you're about 5 times as likely to die from a crash if you're older than if you're younger. So you want to interpret it something like that. I will write that one. Here's a word that's a bit confusing. You're about 5 times more likely. I don't like the word more because if this number came out as 1, you would say there are 1 times more likely. And 1 actually means exactly the same. So I like to say 5 times as likely. So you're about 5 times as likely to die from a crash if you're not 30, 40. I'm above 30, so that's not good. Okay, so that would give you your another merit mark if you needed it. Alright, then you guys went on to try to explain why this might be the case. And there were some good ones. Most people said old people are brittle. That was quite good. Which is sort of true. Yes, there are more complications you could have if you're older. Some people said, well, maybe it's not really the crash that's killing you. The crash is just helping you die, that you're getting a heart attack as a result of a crash and things like that. What you should also observe is that these numbers are actually very, very small compared to how many people are in New Zealand. 2 people under 40 died. 7 people above 40 died. That's possibly just randomness. If we did this in another year, those numbers could easily switch around a bit more. We don't really know that it's the oldness that's been the reason for this. So it could be randomness as well, because these numbers are really quite small. It could be the type of riding they're doing. So young people ride bikes. They often do it within suburban neighborhoods and things like that. A lot of the older people who ride bikes often go out and do it on roads. They do road cycling for fitness and things like that. So maybe that's the reason. When they are involved in a crash on a big open road, it's a lot more likely to result in death. So perhaps it's not the fact that they're older, it's the type of riding that they're doing that's creating more deaths. So those are some extra options you could talk about there. All right? Yeah, I won't write those down. They'll just take a little bit too long. So yeah, the best mark you could have got down here was an E7, and that would have been from getting a good contextual reason backed up with these numbers from this question. Remember, if you only answered this question overall, you could still get 7 marks from it. All right, so don't avoid the excellence question. You could have a bit of luck there and get lots of points out of it. All right, so I'm going to stop that there and move on to the next question. So we've got separate